Okay guys, so in the last few chapters we've been talking about how to prove triangle congruence. Quick review of these methods. We can use side, 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 angle, side, angle, side, angle, 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 side, or the hypotenuse-like theorem, only for right triangles. Go back and Google these, Khan Academy, watch my other videos if you need a review on those. Okay, so now we're just going to work on proving triangle congruence using these methods. So for our first diagram, we're trying to prove that angle Q right here is congruent to angle T. Notice that this question is essentially asking us to prove that these two polygons are congruent, because if we know that, we can infer that these corresponding angles are going to be equal to one another. So what do we know? We know that this side is congruent to this side, and we know that this side is congruent to that side. Okay, could we use side, side, side? We probably can't find the lengths of the third side, and thus we can't prove they're congruent to one another. For side, angle, side, however, notice that we can use the vertical angles theorem here. That means that this angle is congruent to this angle. Side, angle, side. SAS, that's how we know that this triangle is congruent to that triangle, and thus angle Q is congruent to angle T. Moving on, now we need to prove that segment AC is congruent to segment DB. Again, we're basically trying to prove that these two triangles are congruent. We know that these two angles are congruent, and they also give us that these two lines are parallel. So what do you think this line is? That's right, a transversal. So now we can use the alternate interior angles theorem to say, okay, this angle is congruent to this angle, and by the reflexive property of congruence, this line, which is shared by the two triangles, is congruent to itself. So we know that's congruent. Okay, that gives us angle, angle, side. Angle, angle, side. And that's what we use to prove congruence here. Thus you know that these two segments are equal. For our last question, it's asking you to prove that angle 1 is equal to angle 2. This is a tricky one. You might look at this diagram and be like, oh my gosh, I have no idea, so many lines, so many angles. What they do give you is that these two angles, if you look at the big triangle as a whole, they are congruent. By the base angles theorem, we know that these two side lengths are congruent. The big triangle is isosceles. Okay, well they also give us that these two angles are congruent. So by angle, side, angle, angle, side, angle, you know that these two outside triangles are congruent. Okay, so now if we look at the middle triangle, if we know these two triangles are congruent, then we know that these two lengths are going to be equal to one another. Thus, by the converse of the base angles theorem, angle 1 is going to be equal to angle 2, because this is also an isosceles triangle. So that is it for page 285.